Hey guys, welcome to part 2. Today we're going to be taking a look at some materials that we can consider to be more engineering worthy. This list will have filaments that are more difficult to use and for the most part more expensive, making this list for more advanced users. First up is ASA. ASA stands for this. I'm not going to try to pronounce that. It's an amazing material. It's very strong, water resistant, chemically resistant, UV resistant, and durable. It's quite a looker too. So it's perfect, right? No. It can produce great products, but at considerable headache. Here are the challenges an ASA user might face: high extruder temperature requirements, high bed temperature requirements, toxic fumes, high energy consumption. Parts are prone to cracking, warping, and shrinking, especially when not cooled down slowly, and not to mention high cost. Many would argue it's worth it, and I can see why. The use cases of ASA filaments are out of reach for most materials. We're talking sporting goods, outdoor fixtures, housing components, and even exterior automotive parts. It's a very powerful and well-rounded filament with tons of strengths and advantages, but it's just a little bit hard to use. Next, we're going to talk about HIPS, or HIPS if you will. It's similar to PVA as it's dissolvable. Not in water though. Instead, HIPS is dissolved in a citrus solvent called limonene. Unlike PVA, it's also suitable to be printed alone, as its strength and stiffness is not unlike that of ABS, making it a versatile option with some interesting applications. This attribute of HIPS also makes it a popular support material for ABS, as the matching strength and stiffness work very well together. HIPS is prone to the same inconveniences as PVA, namely clogs and airtight storages, plus it makes quite a mess when you do dissolve it. Next we'll talk about PC, or polycarbonate. Yes, I can pronounce that one. It's a material known for heat resistance, very impressive toughness, and surface clarity as well. PC even comes in some interesting variants. Most notable is the translucent types. Comparisons to ASA are apt, as the same challenges apply to an even higher degree, but the results are very impressive, especially if you're looking after strength. PC can also be bought with variants blended with either ABS or ASA, improving ductility and processability for the ABS blend and increasing UV resistance with the ASA blends, which makes it a lot more usable outside. Expect to pay more for these materials, as we're really getting up there in the more advanced stuff. Next up is a filament simply referred to as flexible. TPE/TPU plastics of different types are used for this type of filament, and with a name like flexible, you can figure out what this filament is known for. I'll even give you 3 guesses, but honestly, the footage speaks for itself. It's basically like printing rubber. It's durable, has low shrinkage during cooling, and doesn't even require a heated bed. However, with its unique properties and applications comes unique printing challenges. Most notably, nozzle temperature and flow rate must be fine-tuned in order to prevent extrusion failure. It's also prone to significant stringing and oozing, which suck, but it's pretty much your only option for properties quite like these. And in terms of 3D printing, properties like these are quite impressive. Last but certainly not least on our list is PVDF. PVDF stands for polyvinylidene difluoride. PVDF is a material known for high strength, purity, and resistance to solvents and acids. In fact, it's completely chemically stable. Not only that, but PVDF has piezoelectric and pyroelectric properties due to its intrinsic ferroelectric formulation. What does that mean? Well, basically, PVDF materials create voltage whenever heated or deformed, making PVDF a material used to 3D print electrical components such as sensors. PVDF is relatively challenging to print because it needs to print very slowly and it suffers from warping while cooling, but it's not as bad as some of the other things on this list, but it's also very expensive, so there's that. But if you're interested in creating custom electronic components, this is one to look out for. Alright, that's it for today's list. Make sure to join us for the next video where we're going to be going over the ultra performance 3D printing materials. Make sure you buy your 3D printers and filaments from density3d.com.